Great. So I'll talk about a small project that I wrote and put online called Vlad the I like thinking of names for programs. I think a lot of scientists have funny names in their programs, but Vlad's helping me stake. It was one of the things I had a problem with a few years ago. I just had a small period where I had more time to work on other things in Numerai and started working on this. And now I've been using this and trusting it for the last half year. Beforehand I was using earlier versions and not trusting them, so it's been improving. So I'll talk you through it, what I was doing. So background history. A few years ago I was having a model called Good Times. It was like a tiny XGBoost model, but with a hill climbing process. So I was just talking with Wolfgang about, hey, I want to diagnostics and then make a programmatic loop where I just can improve the model or do hyper-parameter fitting. And in this case, the hill climbing was doing, trying to figure out what areas to train on. So I don't want to train on all areas because some of them are like overrepresented in the data set and others are not. So how do I do that? And this small hill climber is just making a variant, like a different subset of areas, and then comparing it against the existing one. And so you just go, if it's better, you take it, and if it's better, you take it. And you might have some variation in there. But that's basically a hill climbing optimization process. Correlation scores were calculated per area. Recently heard Mike Oliver talk about it. He's still trying to get XGBoost to, or what is it, like GBM, to be able to work on, to understand the concept of errors, which is in the data but not in these models. But of course, once you have the predictions, you can calculate just the scores. And then I had funny thing is I had a fitness function that was optimizing for the mean of like the top half of the error. So I was just ignoring all the grunts that the model was doing. It was sort of hill climbing itself towards what was overly present in the data. So you're sort of overfitting. So it becomes like a caricature of the average XGBoost model, but more extreme because it wasn't sort of dampened by the burn errors. So that worked pretty well because we had more good errors than burn errors. But you get insane volatility. It does very well or it does very badly. And that is not my personality. I don't like it. So after a few of these burns, I wanted something else. And then there was a comment of Richard Craig, and I'm not sure if this was still in the Slack era or the Rocket Chat era. We're now in the Discord era. But he made a point like, so people don't spend enough time thinking about state allocation. Everybody's building models, improving models, trying to get them better. And then you look at your 4 models, you pick your best one and you pump all your NMR on that one. So spend more time on state allocation. So then, yeah, I had some point in time where I actually started doing that. The problem of state allocation is basically the same as stock allocation. If you have, in terms of finance, it becomes like a long-only kind of stock allocation. You have 2 markets, core and DC, and you have different versions of leverage allowed for both of these tournaments. That's fairly straightforward. So first one I did was just in the language I've been using for everything, which is Clojure. It's a list from the AVM, and just go and brute force, pick 4 or 5 models that I like, and then brute force different NMR allocations and core and DC multipliers, and then look for kind of what's the sharp I get out of this if I would combine these things. But there is like a whole field of theory about this in finance, so at some point I dropped my own little thing and picked up an R package, the F portfolio. What I do normally in science as well is first try to go fancy and then go back to simple. So I first went for fancy. With F portfolio, so I was building faking time series based on covariance matrices between my model scores. So you know how your models co-correlate over time. Like, are 2 getting the same kind of predictions or are they different predictions? So you get a covariance matrix between all your models, and you can use the matrix to also generate new time series. So then you can sort of fake it what your models would do like in the long term. Third version was actually not doing all this robust stuff and go back to some resampling using the R package. So I'll talk you through the second and third model because the first one is just simple. So I have portfolio wants a complete time series, and I continuously add models, so I never have a complete time series unless I just say like, unless I throw away most of the data and just use the overlapping data of the last models I added. So that was a bit annoying. And there, that's why I used this covariance matrix and built a virtual time series from that. But if you do that, like you get into robust covariance matrix estimation, robust center estimation, so mean estimation, and all these things have a ton of assumptions underneath them. So, and some of them are really not suitable to Numerai, I think, because I was looking at this and it was changing way too much. It didn't feel robust at all. That happens if you are in an extreme case. Numerai is an extreme case in terms of how things work. But I've also had things in my data science where, looking at autocorrelations, all these packages didn't expect me to miss 95% of my data, and I missed 95% of my data in the autocorrelation tests I was doing. So that broke down as well. So Numerai is pretty special. So this stuff that should work in time series for like the stock market, where you tend to have almost complete data, doesn't necessarily translate to Numerai. I was using daily interim performance as well. This was before the daily tournament started, and it never really felt good. I tried staking on them, and then I was changing the stakes myself because I really didn't believe what was coming out. So it was like a good testing period before I exposed it to anybody else. Because I went to like a different way, like more simple. So with the daily tournament, you get correlated, but more frequent final scores of your model, so it doesn't take forever to get like a sample of final scores for your models. And I just don't do the time series generation anymore. You just use a subset of the performances that overlap between the models. But then you have to make some decisions on which models do I include to not make the subset too small. So I'll talk you through this one in more detail so that you actually know what the package is doing. If you want to use it, absolutely do, but then it's nice to know in default what it's doing. So, first thing, input. I've been working with, for my day job with historians and all sorts of stuff, so you learn that providing a CSV is already sort of complex for some people, so I wanted to make the entry barrier quite low, so what you have to provide is just an Excel sheet with model name, starting era, last era, and some, if you want, some notes. In this example, I'm using a bunch of the models from Numerai itself. So the Vlad reads in the Excel sheet, and you sort of say when you want to start and when you want it to end in eras, and that functionality is built in because I used to sort of reuse model slots. So I had a model, and at some point I stopped it, and then later on I started. I don't want that whole time series because it's two different models. So I want to say, okay, from this point onward you can trust it. So it's not super flexible. If you do really fancy things with model swapping between slots, then it will get confused and you'll have to do some manual work to provide a data set. But if it's very simple what you do, just from here onwards, it's okay. Then you can just specify it here. I think this human needs a gimbal or something like to stabilize it. So it is, so you can stake in both core and TC. But if you want to do like a portfolio optimizer, it works better if you think of it as two different models. So your single model scoring on, like Victor on the top here, scoring on core, and scoring something different on TC. Just treat it in your mind as two different stocks, two different models, and then you can actually run this kind of software on it. But first, just look at the mean and the standard deviation of these models. So for the core, and numerized models are all actually positive. For TC, it's another, I don't show the plot here, but half of them is positive and half of them is negative. And here you can sort of see which models are doing well, and anything on the left has less variation, and anything on the right has more variation. And that's just simple, just for yourself to, after the model Vlad decides what the stakes is, you can go back to these graphs and see if you understand that this makes sense, that it's sort of a feedback where you can check what the model predicts, because now you have a little bit of overview of how your models are doing. And you don't see how correlated the models are between themselves, but you do see sort of where they fall in a mean versus standard deviation plot. So it's good to have this feedback when you learn and trust things like Vlad. So one of the thresholds I do is I only consider models that are positive. In theory, models that are on average negative might still add in an ensemble. Yeah, I just felt like I just do the positive ones because it's again something where for myself it was just a matter of I do trust it more if it's actually a positive model that it does something good in an ensemble. But you can just remove that criterion if you want. And then indeed we look at the overlap between the models you have, and I would say get at least 60 result days of scores for it to work. So your newest model cannot sort of be added within 2 days or within 10 days. Get 60 days of scores, and then so after 3 months you sort of can start including these models. And the 60 days is just from experience where you see that okay, after that it doesn't change that much. It seems to be not like hyper sensitive to another week where the outcome changes. So as I said, I want stability. I don't want to drastically redistribute my stakes every week. Just because it takes forever, even if you do things like having stake slots, which I talked a little bit about in the Discord. But I have all my models, they have their own slots, and I have like 7 stake slots, and then I can just swap duplicate models and swap them in these slots. Or remove them, so I don't have to transfer stake by pulling it out, wait for a month, and then putting the pulled out NMR somewhere else. You just can immediately switch the models. But having that as separate slots, like have 5 or 7 slots for that is actually working quite fast. Eventually, if we want real stake management, then you could have 100 of these slots. You could just allocate 10 NMR to every slot, and then if you want to have one model with 50 NMR on it, you just put it in 5 of these slots. So there is a way that Numerai could do stake allocation, but they haven't picked that one up. But if you have just 5 slots, you might still have to do a little bit like withdrawing or cancelling withdrawals or adding some Numerai. But you have some form of stake management that sort of works. Stability comes with longer time series, you know better what to do. And one of the things I added to the model is just not only just use time series, but rerun this portfolio functions like 40 times with resampling in time series. So if the time series is 60 long, it just randomly draws 60 rows from this thing. So there are rules and implications. On average, you have 2/3 of your time series when you resample. And that adds a little bit of stability as well between weeks, and it doesn't change so much what it wants stakes on. There's a bunch of different goals you can specify when you're optimizing a portfolio, and this F portfolio package comes from RR Metrics, and it's quite a nice document where they explain a lot. But it's not my field at all, so I didn't delve into the theory behind it and stuff like that. But it is actually it's people working on this, so it's nice. So here's some of the stuff I don't understand, but which I can explain a bit. And you can ask ChatGPT and get quite a decent answer, at least for someone who's a novice. So there's something that is a theoretical description of the trade-off between higher returns and higher variance. And incidentally, the last burn Numerai fund just had was when they loosened up the volatility of their optimizer. So they just went for, okay, I'll take more risk and hopefully get a higher return. So they immediately got the higher burn than they ever had before. But that is this, basically the upper half of this, does it have a pointer also?
Yeah, in the middle.
Yeah. And in the middle one, yeah. So I don't know what this thing is doing here, the downside line, but most of this theoretical description is in this part where you can increase your volatility and get some increase in returns. And then there's points on this theoretical line, and I don't know how they construct this theoretical description. But where, okay, this is where you have some positive return, but you have minimal variation in your expected returns. And that's then your min variance portfolio. And there's here one that's called a tendency portfolio, and that's because there's like, if you draw a straight line across the sort of this asymptote, this is the point where it hits it. So it's lower here, it's lower there. and that's called the tendency portfolio. This one still has more deviation returns than this one, and actually what Vlad is doing, because this is what I sort of liked, was taking the average between those two portfolios. These are all things you can just easily change yourself. It's a little bit of art, but you just disable one line, and you're taking one or the other, if you have an opinion on that. Let's see. So output. So as I said, all 2020 Numerai exam models had a positive score, but only 10 had a positive TC. So also for them, it's hard to get TC. Might be the PDM1 minus P thing for them as well. If you run it through Vlad, only 4 of them make it through the selection to be state-weighted integration test from like way back. I think this is still running on version 3 of the data, maybe. I'm not sure what it's running on these days actually. And then there's Jerome 20, Type 20, and Victor 20. We just had Numerai themselves talk about and posted, hey, Jerome 20 is doing better than all the new targets we have, and we don't know why, and we're trying to figure it out. So it's a nice sort of confirmation for me that Vlad thinks Jerome 20 is something to invest in. And let's see if I did the right thing. Yeah. So what comes out of Vlad? First it says which models it wants included. So it's just 4 of the 22 models. Then it says 2 of them are actually where you should invest in core, like the core tournament. And 3 of them is where you should invest in DC and join the DC tournament. So this would be 5 stake slots in total, but sometimes you can merge stake slots. So here I'm just looking, is there a weight in NMR I want to allocate on core and a weight in NMR I want to allocate on DC that by accident sort of matches? So if integration tests had a little bit better TC, then maybe you could have done a one-time core 0.5 times TC with a single stake slot. But in this case, it looks like it just wants 30 on 190 if you do TC times 0.5, but then you can also just do a separate slot and use 30 TC, 30 Numerai on a separate stake slot. So to follow up with what Vlad suggests here, you need 5 stake slots, and then you get ensemble, not the ensemble, but stake distribution that Vlad recommends. And of course, it's not just for stake distribution. You could use it yourself as well if you want to build your own meta model. I'm not sure if that works well between core and TC. I haven't thought that much about it. I think because all my models are basically core, it's easy to say, okay, the distribution of core weights I can also use to make an ensemble model where I use the same distribution of core weights. But I haven't given it full thought if you can mix core and TC for a meta model. The other table that Vlad puts out is like the performance characteristics of its portfolio. It compares this to the tendency portfolio, the mean variance portfolio, and the portfolios based on the individual models that are making up the portfolio. So you can just sort of look and compare here. Let's see, did I do the thing as well? Yeah. And so here you have your mean, your expected return basically. So the portfolio has it's all quite low actually, 0.07 these days. But everybody's burning a bit. The tendency is a little bit higher, mean variance is a little bit lower, what you expect. But then in risk, you also have, these are small differences for these models. So they have quite high risk actually. CVAR and VAR have specific meanings in finance, so you can look those up as well. But it's a little bit of the size of the burn you can expect and how often the burns come. I guess it's the upper edge of the size of the burn you can expect, something like that. And you see here that the portfolio is doing quite a bit better on average returns than the individual models are doing. So it's still quite a bit of risk, but like all these models are trained sort of in the same way. They're just using different targets. So they don't consider per error performance. They're just sort of going for what's on average doing well. So if you have models that are more diverse or doing more funky things, actually your risk can be quite a bit lower, and mine are about half the risk of this. But also a little bit more than half the performance. So that's the trade-off here. Let's see. So churn, You also don't want to change your state completely every week, that everything changes, because it doesn't feel like too robust in a way. So here's a change of about 2 months period in time. We went from 140 scores to 178 scores, so it's almost 2 months of tournament. And some things changed. So you see integration test is still there, your ROM is still there, Tyler is still there. That's Victor joined and got about 25% of the portfolio. Rolf and Waldo were dropped for about 70% of the portfolio. Integration tests changed the stake a little bit. They went from sort of equal core and TC to more core and less TC. So there are some changes that are happening, but I'm not updating weekly my own weights now. I just every so often I rewrite the program and then adjust the weights. You also see that the mean performance has been dropping. That's just basically, we had another 2 months where there was a decent growing there as well. But I can compare these models. So this I tried to fix this morning, but I didn't have enough time to actually get it completely comparable between my models and those of Numerai. So this is covering the same time period, but because they started immediately submitting daily when the program started, and I took a while before I switched from weekly to daily. I have a lower sample size. But you see sort of the differences. Like my portfolio it's over half, but it's quite a bit lower than 0.07. But the risk is also quite a bit lower, and that's because my models are now really trained on one of the fitness criteria is to have as little burn as possible across the eras. So things like that lower your mean average if you sort of require a night to sleep. I think that's most of what I wanted to talk about. Yeah, I like having Mark and Darwin and Wallace in the same cluster. So Vlad is waiting for you. You can just get it at GitHub. If you have any questions, so one last comment to make. Somebody else saw this and almost immediately also built some Python version of with state management. So there's now actually two of these, which is good, so you can compare it, and he'll be making different assumptions and trade-offs. But I would really recommend looking into something like this just to figure out how to position states, because it feels sensible to me. Like I'm happy that I did this, and then I'm using it for everything I do. Okay, that's it. Any questions? Vlad the Staker is, I think he's the historical character that became Dracula or something like that.
Yeah, dealer of the Turks.
I didn't need it.
He was the vampire.
The vampire.
Yeah, vampire.
No, but yeah.
From
I was just thinking about
Slovakia.
I was just thinking about these staking and we're staking, and my mind went through there. What kind of stakers do I know?
I have a question. How do you do the resampling of the time series?
Just very simple sample with returning sample. So you just, if you have 100 numbers, you just 100 times pull random from this range of 100.
Okay.
Yeah.
Just simple one.
Yeah, super simple. Yeah, I guess you could go deeper into this whole thing, but I like sort of the theory in portfolio building to actually go deeper. And this was a good enough improvement for me, like I think a pretty huge improvement for me compared to what I was doing before. So now I'm switching back to the building models.
When you're building new models, how do you do that? I guess you just need to wait then 60 days or 100 days until you can actually start setting them up.
Yeah, I think that's sensible anyway.
But then it ruins the rest of your data as well, right?
So one of the things I do is I run it a few times with including different cohorts of models. So I can just set a sort of the cutoff era in there and say, okay, so the oldest era I'm considering is 340, or the oldest era I'm considering is 400 or 416, and it just filters out. And you can see how much difference that makes. So there's still a manual component there but this is still good while I'm still sort of getting used to this. So I can run it with the newest models after 60 days, and then then it will just consider the last 60 days. And you say, okay, it's also a more recent sample, so it might be good if you're chasing regimes. But you can also take a longer one and just cast out these models that are incomplete. So there's some variants you can use. Yeah?
Do you also use it to guide you which model you should be building next? Like need a core model or need a PC model or?
I'll be releasing basically my model soonish. Like the one I'm using now, it doesn't have really a track record that it works yet, so it's easy to release it. But it's a genetic algorithm, so it's fun to just show it off at some point in time. But one of the things it's doing is it has a fitness function like score on a few of these, like Victor or Waldo or Nomi, and take the minimum score, minimum performance score on this per era. Like say, okay, we're not going to take the average score per era for these things, but say, what is your worst score there? So you can do something like that. And I had picked some eras. I just basically took the last 2 batches of eras that were released. But now I was looking at this and thinking, I could just use the TC and core quality of all these example models they made and say, hey, maybe I should just give as criteria the top 4 or 5 models there and try that as a default. I have models where one of the things I was optimizing is which eras to train against or which targets to train against. But the more of these things you add, the slower and more complex your searching space becomes. So there's trade-offs. But yeah, you could just use the mean, and this is not like fancy, it's just showing the mean and standard deviation, but you could use those to decide what targets to train against.
So here you build an APD DOM.
Yeah.
I think like the other guy, he also mentioned something about showing the models. I didn't quite get, like I could be wrong, but I didn't quite get how you can show the model. Like I don't know.
You invert predictions.
Sorry?
You just invert the predictions.
Ah.
One speed.
But does that just give the input
Yeah.
to see?
Yeah. It's stupid, but it does. Yeah.
It doesn't really make sense to me.
No, but it's a good point. No, I didn't do the short because I was thinking about as far as you were doing.
Yeah.
But yeah, if you combine with one-line speed, you can actually invert your models, but it feels wrong to do that in a way. Like, you build your model to do well, and then you say, I'll just do the opposite. But it's also the reason why I dropped out all the models that were having negative averages in the ensemble. But if you're going full on for, I trust this, you could say, allow negative models or inverted models, and go for a short design. Oh, that's cool that there's diversity in these stake optimizers that you could take into consideration.
What other file types can we use? Mention CSV, in JSON views, or structure, non-structure, real-time data?
It's just anything you can load into R is fine into the data frame of R. But this was just if you only know how to type R script and optimize me.r, then that's all you need to know to run this. But yeah, if you know a little bit of R, you can just pull in whatever data you want.
I know only Python, should I switch to R?
No, maybe use the other package, because that one is in Python. So there's a link on Vlad's data to the Python package. And there's a link to Vlad's data on the Python package on which as well. So yeah, I would just start with exploring the other one then. Or try the Excel thing and just run it.
Have you tried plugging a random model?
How that does? No, I don't have any random models that have a history, but there might be some. If you know some, it might be interesting because
I think somebody mentioned random model on the forum.
Yeah, there's some people running random models.
But I'm not sure if it was signals or.
I think also with the tournament. Yeah, I could add them to the example if I figured them out, because it seems that quite often what a random model does is just dampen the direction you're going in with the other models. And that seems to be quite often good. Like, too often the people are overfitting or pushing too far into a small direction, so random sort of brings them down. And that sometimes works. Cool. One more.
Are you using neutralization in your models? So you could also add like neutralized versions in there, like some models with neutralized.
Like, yeah, I haven't done show the plot, but feature neutralization, no, 7, feature neutralization.
Okay.
So these are, WS means the weight state model, so I think that's where I have a correlation function which overemphasizes the edges of the correlation. Like, what now has become the new core function. So yeah, it seems like my feature neutralization models that went out of vogue are actually the ones that it likes best. And then the EN, I have an EN or GN variant. GN says, okay, I'll just use a global neutralization, so I guess the whole thing, and EN is per error neutralization. And that still feels a bit weird to me, but it seems to work, where you neutralize for every time you neutralize against, for every error you neutralize against these other, what is it? 350 functions or something, or 350 features that are in the JSON file. Yeah, so it still seems worthwhile to use feature neutralization to some degree. Although it got out of focus. First it was the memes with all you need is feature neutralization, it makes everything better. I think we had one of our characters from Game of Thrones in there. Yeah. But that got out of focus at some point when the markets changed, and it might get more into focus again.
Happy?